Wonderful people, now that we are in our second tutorial of grade 11 functions, let's just try to turn the pages and see now what we can learn out of this. So let me just draw up a line here. Very good. Now, for example, we want to do the following. Now remember, we said that drawing the straight line graph, you require the equation in the standard form, y equals mx plus c. You require the vertical translation. You require the y-intercept letting x be 0. You require the y-intercept letting x be 0, the x-intercept letting y be 0, and the gradient, which is the coefficient of x when the equation is in the standard form. And we said that the standard form of a straight line function is y equals mx plus q or plus c, where q or c is the y-intercept, or it is the a vertical translation of the function. So let us look at an example. Suppose they say that we should draw the graph of the following. We should draw the graph of x and y, which is mapped onto x plus 2y equals 4. This is how I would read this. X and y mapped into x plus 2y equals to 4. And the first thing that we will do here is to try and write this in a standard form. So I would just say x plus 2y equals 4, which is the standard form of the straight line. Okay, is this the standard form? No, it is not yet the standard form, because the standard form y must be on its own and you must have mx plus q on the other side. So this is not the standard form. And how do I make this or write this in a standard form? I will make y the subject of the formula. So I will have my 2y equals, I have my 4. Take this x, which is positive, when it goes to the other side of the equal sign, it becomes negative. And then I'm looking for y, not 2y. I will divide everything by 2. 2 into 2 goes once. Somebody can say they cancel. That is fine, as long as you understand what is happening. And then you will have your y being equals to 2 minus this can be written as 1/2 x, for x times 1 is x. Some of you do not know the basics, so we must try to cater for that. And remember the standard form, it has to be mx. So let me just rewrite this as negative 1/2 x plus 2, because this is positive. Let me just rewrite it nicely. What is this? This is the standard form. Y equals mx plus q. Can you see that? All right. Be that as it may, what is it that we need to do now? I have the vertical translation, which is 2. That is fine. What else is needed? X and y intercepts. Because I have the basic shape of the graph, the gradient is negative. I know how it would look like. It would go like this, just as we have learned in the previous tutorial. We know that if the gradient is negative, it goes like that, and if it is positive, it goes like this. Okay. Now that we know how the basic shape of the function would be, and this will position the coordinates on the line, what else is left here? I need to find the x and the y intercepts. I know they said that for x intercept, I must let y be 0. So where I see y, I'm writing a 0. I want to make x the subject of the formula by solving for x. Take this to the other side. Okay, and now I want to be left with only the value of x. I want to get rid of the denominator. I will multiply both sides by 2. 2 times negative 2, it's negative 4. 2 into 2 goes once, because you are a numerator, you are a denominator, and you are the same. You will go once into each other. You are left with negative 1 times x, which is negative x. I'm not looking for negative x. I want the value of x. There's a 1 there. Therefore, I divide both left and right by negative 1. Because whatever that you do on the left, please, you must also do on the right. Negative divided by negative is positive. 1 divided by 4 is a 4. And this divided by this is a positive. Because you can say this into this goes once, and you are left with your x. I don't know if this is clear, but I believe it is more than clear. So we have the x-intercept, which is 4. So I know when x is 4, y is 0. That's exactly what I said. And when we write our coordinate, we start first with x, then y. Always and always. So that is fine. I have my x-intercept. I need now to find the y-intercept. For y-intercept, x is equals to 0. Okay. I have the equation y equals negative 1/2 x plus 2, which is the standard 4. There it is. Now I want to find the y-intercept by letting x be 0. So where I see x, I'm writing 0. And why am I putting in the brackets? To show that there's multiplication between this number and x. Anything multiplied by 0 is 0. 0 plus 2 will always give you a 2. So when x is 0, y is 2. Okay, always starting with x first and then y secondly. Can I draw the straight line now? Yes. This is my x and this is my y. When x is 4, suppose here it's 4, y is 0. When x is 0, y is 2, suppose the 2 is here. Draw the straight line. There we go. The gradient was able to give us the basic shape of the graph, and the basic shape of the graph positioned these values on the line as you rise and run. As you rise and run, you are being positioned by the shape of the graph, which is a negative gradient. So this is how the graph would look like. It will intercept the x at 4 and intercept the y at 2. I hope that we are more than fine with this. Let's turn the pages and see what else they have for us. Right, suppose now that you are not given the equation. This method was being used when the equation is given. You just find x and y intercept and you draw the basic shape of the graph and you positioned your coordinates. Now, what if you want to determine the equation of a straight line? And you are not given the equation, you are given some points, and you would like to find the coordinates of x and y. Let's read what they have to say to us. It is much more easier to use the equation. They say y minus y1 equals m into x minus x1. It is much easier to use this equation that you have or will learn in the analytical geometry. Okay, the value of m, which is the gradient, and the point must be determined. These values are then substituted back into the equation. That is fine. To find m, which is the gradient, Find m by using one of the following methods. Okay, if the line passes through 2 points, they say that the gradient, it's always equals to y2 minus y1 x2 minus x1, which we can say y final, y initial, x final as x initial. And we know that they say for parallel lines, the gradient of the first line equals the gradient of the second line for parallel lines. Okay, no problem, we fully understand that. All right, and then given the angle of the line with the x-axis inclination, they say that the gradient equals tan theta. So meaning if you are given an inclination, which is an angle that the line makes with the positive x-axis, you would find the gradient by saying the tan of the angle that is provided, or the angle that the line makes with the x-axis. Okay, how do we complete this equation? The last value required in any equation is found by substituting a given point for x and y into the equation found so far, and hence solve for q. Remember that q is the vertical translation, so if it is given, then you can use it. That is fine. Now let us look at an example of this. They say determine the equation of a straight line passing through the point -2 and 1, 4 and 7. So 2 points are being provided, and they want us to find the equation of a line. And we saw this, that with 2 points, anything is possible. You just require 2 points in order to find the equation of a straight line. So they said we should first find the gradient, where the gradient is defined by this. So meaning in our points here, I'm going to say this is x1, y1. For every x1 you will have a y1, and for every x2 you will have a y2. I hope that we understand that, so that we can say the gradient equals y2 minus y1, x2 minus x1. And we have our y2, which is 7 minus 1, our x2 as 4 minus into what is my x1, -2. This is very, very important. What is 7 minus 1? That is 6. Negative times negative is a positive. And you would find 6 divided by 6. 6 into 6 goes once. And this is what you find as your gradient. And then after finding the value of this gradient, which you found as 1, we would pick any point from the 2 points that you used to find the gradient. You pick any point, and then you use that point to find the equation. So I'm going to pick -2 and 1. And we write first the equation. Y equals mx plus c, or you can say y minus y1 equals m into x minus x1. So where we see x and y, we substitute these values. So I am here, my y is 1, my gradient is 1, my x it's -2, and I'm looking for the value of c. I have my 1 times -2, it's -2 plus c. Take to the other side, c is equals to 3. And now we write y equals mx plus c. I write down the value of the gradient, that is 1 times x. Then I write down the value of c, which is +3. 1 times x is x plus 3. So this becomes the equation of this line. With a positive gradient, I know that it will have that basic shape and the coordinate will align themselves with this straight line. Okay, that is fine. I think I understand this. So when I'm given 2 points and I am to find the equation of a straight line, I will name those coordinates as x1, y1, x2, y2. Substitute into the formula of finding the gradient. After finding the gradient, pick 1 point from those 2 points, substitute them into y equals mx plus c. Where you see y, you write 1, and where you see x, you write minus 2. Where you see m, you write the gradient, and you are looking for the value of c. And then you just deal with that. Alright, I will assume that you have understood the fundamentals that governs the behavior and the function of a straight line. Now let us look at some examples. Suppose they want us to sketch the following. I'm going to give you yours and I'm going to solve mine. So I have I think 1, 2, 3, 4, 5. I will deal with 3 and leave 2 for you to solve. Sketch the graph of the function. We are given that f at x equals minus x minus 2. They want us to sketch. And now that the equation is provided, all we need to do is to find x and y intercept. I know that my vertical translation, the value of q is minus 2. That is fine. The gradient is negative, and therefore I know that if the gradient is positive, this is the shape. If it is positive, it will be like this, and if it is negative, it would be like that. So now that it is negative, I know what I'm dealing with. I'm dealing with a function that goes in that way. Now I want to sketch this. The first thing that I need to do is to find x and y intercept. X intercept y is equals to 0. 0 equals minus x plus 2. Take this to the other side so that your x is 2. Because if you take this to the other side, it becomes positive and you have your 2. So when x is 2, y is 0. And that's the first point. The second one, for y intercept x is equals to 0. So y equals minus minus 2. So x is 0, y equals negative into 0 minus 2, which is minus 2. So when x is 0, y is minus 2. Now let me draw the function. When x is 0, y is 2. So let's just say this is 2. And when y is negative 2, y is 0. So here we are. So when the gradient is negative, this is the shape that we have. We're going in that direction. Something is happening here. Sorry, I wrote this in a wrong way. Can you see this? I have made some mistake. This is a negative. I'm very sorry. So meaning this is negative 2. I'm very sorry for that. So meaning x is negative 2. I'm very sorry for that. And this one remains exactly the way it is. And what made me realize that mistake? It's because of this. I know that when the gradient is negative, this is the shape. Positive, this is the shape. So the gradient is negative, this is the shape. So this is the function that I have. So there was just an error that was being made there. So this is the first one, and I am going to solve the second one. They say x and y mapped onto 2x minus y plus 3 equals to 0. And this is what I have. So the first thing I will do is to write this in a standard form. 2x minus y plus 3 equals to 0. Remember, writing in a standard form requires that you make y the subject of the formula. So I'll have my minus y equals, take this to the other side, negative, take this to the other side, negative. Divide everything by negative 1, there's a 1 there, remember. And then you will have your y equals negative divided by negative is positive, negative divided by negative is a positive. 1 into 2 goes 2 times, 1 into 3 goes 3 times, 1 into y goes y times. So this is the standard form. And then from here, in order to draw the graph, I require x and y intercept. X-intercept, y is 0. Where I see y, I'm writing a 0. Take to the other side. Divide by 2 because you are looking for x. This into this goes once. And this is negative 3.5. This is your x. So when x is negative 3.5, y is 0. And for y-intercept, x is equals to 0. So y equals 2 into 0 plus 3. Okay. And then from here, I have my 3. When x is 0, y is 3. And I can draw this. I know that the value of x, it's negative 3.5. So let's say maybe negative 3.5, it's in here. And y, it's 3, let's say 3, it's in there. And because the gradient, it's positive, I know that I'm looking at something like this. And the basic shape of the graph positions the coordinates that I have. And I know that the rate of change is constant. Not the same, but constant. Okay? So let me just try and solve the last one. They say that k at x is equals to 2. And I can rewrite this as y equals 2. And I can try to draw up this line because I cannot find x and y intercept. This is y, this is x, y, it's 2. Where is that? There it is. And what is the gradient here? The gradient is 0 because this can be written as y equals mx plus q, where the gradient is 0 into x plus 2. Where 2 is the vertical translation. 0 times x is 0, so you have 0 plus 2, so you have a gradient of 0. So is this a function? Yes, because for different values of x you can have the same value of y, but you cannot have this you cannot have a function if you have the same value of x for different values of y. We have talked about that in the previous tutorial. So this is what we have. This is exactly what we have. So I'm going to leave it here, and then in the second tutorial we will wrap up the straight lines, where we will be looking at the straight line that passes through a point which is parallel to this, perpendicular to that, having an inclination of whatsoever value that can be provided. So I'm going to break it here, and in the third tutorial we will continue with all that.